Good morning everybody. Today I will start the class based on multiphase flow. So here actually it is not multiphase flow, it is actually emulsion flow. So in previous lecture we have seen single phase flow through tubing. Now we have two more topics. One is emulsion transport through tubing, another is gas, oil or water mixture through tubing. So today's lecture is about emulsion, how emulsion works. So first let's see the wellbore. Wellbore is like this and you have tubing. All right, in previous lecture we have seen this casing is there and inside tubing, and there will be one wellhead to choke to separator to your customer or your refineries or transport line it will go. And when oil and gas is entering into wellbore, it will have oil plus water plus gas plus sand. So definitely it is not a single phase flow, it is having multiple phases and multiple component also. So phases, we assume in thermodynamics phase is defined as like gas, solid, liquid. But when two liquids are mixing together, for example oil and water, so in that case normally we say multi-component flow, sometimes say multi-phase flow. So when we consider oil or water plus gas, that is actually multi-phase, and when we are considering oil and water, so that is creating a emulsion flow, sometimes a mixed flow. Now when we have emulsion flow, how this viscosity will change and why viscosity relevant to your artificial lifting system, because this course is related to artificial lift. Viscosity means resistance to flow, or inverse of viscosity is the fluidity. If viscosity is changing, then your resistance is changing. When resistance changing means pressure drop is changing, your pump must be working hard to lift the fluid. So if you have changed water cut or water percentage in oil, or certain amount of more water you are adding because of maybe your reservoir property changed, because of that reason you are getting more water, so that water will give more viscosity. More viscosity means more resistance to flow, means more pressure drop. So if you install already one ESP or sucker rod pump or jet pump or eject or gas lift, in that case that energy, whatever energy you are supplying through your pump, that energy may not be sufficient. Sometimes the pump may not work also because of the viscosity change. So you have to know the emulsion properties, how it is working and how it is affecting the viscosity, and finally it will be affecting the artificial lifting system or whole production system. So if we want to understand emulsion, then we have to understand the flow physics, reservoir properties, then how to correlate, how to formulate, I will discuss in this lecture. So emulsion is the definition. Emulsion definition is that two immiscible fluid mixed together. So for example immiscible fluid may be oil and water. For example this one, it is having two fluid in this bottle. You can see one is having water, another portion is having oil. So when oil and water is mixed together, let's say this way we mix, what happens, oil and water will be mixing, but normally oil and water will be separating quickly. There will be very little settling time, so very short time it will be separated. But if we have some sort of chemical which will be preventing the separation, so in that case your oil and water will not get separated easily. That will create stable emulsion. So that stability means, like you have seen, like lots of gels will come for your hair and lots of medicine will come with lots of emulsion suspended particles in one fluid. Maybe suspended particle may be solid or maybe other type of liquid. So that suspended particle will not be settled quickly. Okay, so if you have more, let's say you have oil, you are adding more water. So amount of water you are adding, that is called water cut. So water cut can be 0%, 10%, 20%, 30%, 80%, 90%. But if you have very high water cut, say more than 95%, so in that case it will not be economical to produce oil and gas. So in that case, maybe you have to abandon the wellbore, or you have to do something to change the reservoir property so that you can get more oil instead of water. For example, some cases people will do chemical injection. Why chemical injection is there? If you inject chemical, then actually you are changing viscosity. Because of viscosity change, your oil and water layer will change, and that oil layer and water layer is separated. So that time maybe you will get more oil instead of water. Again, in a wellbore's life, you are producing more water than oil or gas, and water is not economical. And if you are producing water more, that means your earning money from wellbore will be very low. So because of economical reason, you do not produce more water. Your target will be to produce oil or gas. Again, if you are producing water on the surface, you have to dispose properly. If you are getting more sand also, again you have to dispose properly. That also will be taking money. So finally you will be losing your money. Okay, so you have to complete wellbore, or you have to see reservoir properties, how to control this oil, gas, water, so that you can get more oil or gas which will be economical, which is beneficial for your company or for your country or for your company. Emulsion. So I already told, if you have oil, let's say I took one bottle and I have water and oil. Water is heavier or high density, high gravity, oil is lighter. So oil will be floating over water. Okay. So normally if you mix petrol and water, or diesel and water, or any oil and water, because particle size is different, polarity different, so it will not be mixing up. If you jerk it properly, if you shake it properly, like if I have bottle, if I shake it properly, what will happen? This will be mixing up, but within very short time, maybe within 1 minute or 2 minutes, maybe sometime few seconds, it will be separating quickly. When the two fluids are getting separated, that means it is unstable emulsion. Okay. So when it is unstable emulsion, that means when you are pumping, so water will be sliding down and oil will be moving up. In separator system, it will be very easy to separate oil and water, but it is creating stable solution. A stable solution, if oil and water mixed and you are getting stable solution, that means you need certain amount of certain chemical or surface active agent, that is called surface active agent, surface active or surfactant. If surface active agent or surfactant is there in oil and water mixture, then that will not allow to settle oil and water quickly. So in that case, it will create stable emulsion. So to break that stability, you have to put another sort of chemical, or you have to put heat, or you have to change certain mechanical chemical properties, so that the small particle will create big particle and it will be settling quickly. Okay. And emulsion is created if very high agitation is there, oil and gas is there. Like for example, I have taken one layer of oil, one layer of water. If I mix properly, I am agitating very nicely, so it will create very small particle of oil and water. So that oil and water mixed with certain chemical that will not allow to settle, it will create good emulsion. And if you don't have that sort of chemical, that surface active chemical or surfactant, then unstable emulsion will be created. There are two types of emulsion is created in the wellbore. One is oil in water, or sometimes people write OWO, oil in water or water in oil. Okay. So oil in water emulsion is that you take one certain amount of oil and small amount of water discretely available like this. So this is oil, this is continuous phase. Continuous phase means the amount of water, oil you have taken larger amount, larger oil and small water particles. So water in, this is water in oil. But if you have opposite, larger amount of water, smaller amount of oil, so in that case we say oil in water. So normally water in oil emulsion will be more stable, water in oil the settling rate will be quickly. And if you have smaller particle, very small particle, that will get more stable emulsion. For example, in air you have lots of dust, very small dust, that is not settling quickly. Okay, this is also creating emulsion. And if you have bigger particle, for example, you take sand and put in water, sand will be settling quickly. But if you make grind sand, very small particle, the sand will be floating for longer period of time, that will create more stable emulsion or maybe suspension. Okay, sometimes they say colloid actually, although colloid and emulsion are different, but many times they will be saying this is almost similar. Whenever you are saying viscosity of emulsion, so first you have to say apparent viscosity. Apparent viscosity mu A. So normally apparent viscosity, whatever you measure the viscosity, apparently you are saying that will be highest when water cut is maybe around 80%, 60 to 80% water cut. Water cut means like you say certain volume of oil and you are adding water small portion, increase, so you are increasing gradually water portion, so that percentage of water increasing. So they say the water cut. So water cut 10%, 5%. So water cut 5% means small amount of water. Water cut 95% means water is dominated, oil is very small amount. So that may be economical for production also. But if you have small amount of water, is very much economical. But if you are changing water cut, say because of certain change in reservoir property, depletion or some other reason, water coming more. So what will happen when water percentage becoming 60, more than 50%, 60 to 80% around, so that time your viscosity will be very high. So when viscosity high, your resistance is high, pressure drop is high, your pump may not work. So you have to understand that. So relative viscosity, mu R equals mu A divided by mu CO. CO means continuous phase viscosity. This is phase. So if you have more continuous phase, like say 95% oil, so 95% oil, that viscosity will be dominating. So there is continuous phase viscosity. Mu A means apparent viscosity. So people will be defining relative viscosity equals mu A by mu CO. Now emulsifier or emulsifying agent, sometimes this is surfactant. So surfactants actually it will have one hydrophilic end, another will be hydrophobic end. The surfactant will look like this. Hydrophilic. This end will be hydrophobic. Hydrophilic head or end or tail, you can say tail or end. So what happens, you get one oil particle and oil particle is in water. Let's say this is my water. Okay, now normally oil particle and water particle will not be mixing up because this is different fluid, different properties are there. Now if you have some surfactant, for example wax, example asphaltene, many others are there. So these will normally have polarity like one hydrophilic end, one hydrophobic end. So what will happen, this asphaltene will be like this. This is oil, this is water. Okay, this hydrophobic end will be entering into oil particle, and hydrophilic phil means love. So hydro loving or water loving part, this is hydrophilic means water loving actually, and hydrophobic means water fearing or water hating. So water hating end will be entering into oil particle. So what happens, hydrophilic water loving part will be protruded to water, and hydrophobic part they will be trying to hide somewhere. So they will get oil is there which is not having water, so they will be entering there. Okay, so one end will be in water, another end will be oil. Okay, now you have many such thing protruding, and another end like nail. All right, it is like this. You can draw any shape, doesn't matter. So just you want to explain like this. Now what will happen? So this hydrophilic and hydrophobic that molecules, it will reduce its surface energy. Okay, if it is reducing surface energy, or so in that case the oil and water will be mixed. Okay, it will not get separate quickly. But if we have the polarity difference, water is having very high polarity, oil is very low polarity. So in that case surface energy is very high, once energy difference is very high, so in that case two fluid will not be mixing up. But because of the surface active agent, the energy is getting reduced. Because of reduction in energy, those oil particle will not try to move. Again, if you have multiple oil particle, for example oil particle 1, oil particle 2, they will not be allowed to collide each other, because surfactant all around is coating one particle. For example, this is one particle coating surfactant, another particle coating surfactant. So they will not come to closer to each other, they will not try to move also. So that will create one stable emulsion. But if you can break that surface coating by somehow, then it will be colliding, and collision also not so easy task. So you have to make some other arrangement also, for example electricity and more collision you have to create artificially mechanically, then collision will be higher, then you can create bigger particle and separation will be quicker. So emulsifying agent or surfactant is having polarity hydrophilic or water loving, hydrophobic, water hating. So that particle like nail, it will be entering into water, and in one portion will be entering into oil. So that will create one coating all around the particle, like discontinuous for a discrete phase. A continuous phase means like the volume of oil is very high, so it is continuous phase. But if volume of water is very high, then that water will be continuous phase. But the discrete particle is called discrete phase. So in my case, this is continuous phase water. Phase is water, and in this case discrete phase is oil. Okay, so oil particles separately here, that is discrete phase. So this is water, oil in water emulsion. In that case, you are giving wax or asphaltene certain chemical to coat the oil surface, oil particle surface, so that oil particle will not try to move, or it will not try to collide each other. When it is colliding each other, it will create bigger particle, it will separate quickly. But normally it will happen because of this surfactant. These are enemy to break the emulsion. So many times we create emulsion, for example hair gel you create. Sometimes oil industry we create emulsion so that oil and water will be mixing together and it will be moved up. And on the surface you need to separate, because refineries they don't want water, they want only oil. But if you are putting oil plus water, they will not buy. So you have to separate in surface, and if you have stable emulsion, difficulty will be increasing, cost will be increasing. But many times you cannot do anything, because wellbore will have asphaltene, wax and this sort of chemical which will be inherently mixed with water and oil, and it will create a stable emulsion. And stable emulsion means it will give higher viscosity means more pumping power, more energy loss. one example of surfactant is sodium dodecyl sulfate. Sodium dodecyl sulfate. So in that case, what happens? You have carbon atom, so it will be chain. Okay, so final chain will be connected to oxygen, oxygen to sulfur, sulfur to sodium, and sulfur is having valency like oxygen, oxygen, and sodium plus, oxygen minus. Okay, and this end is having H3C, H3, H, 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 H. So this a hydrophobic tail. This is hydrophobic tail. This is hydrophilic tail. Because it is having O minus ion. O minus will and water will have H plus. So O minus H plus, it will create bonding, and that will be creating as a hydrophilic water loving end, and other end it will be hydrophobic tail, which will be linked with water, because hydrophobic end don't like water, so they want to go away from water. So what will they do? They will enter into oil, so they will feel I am safe, no water is attacking me. Okay, so that will it will create one bonding, and it will be coating the surface of oil particle, and it will create one stable emulsion. Okay, so Newtonian Nortonian fluid for emulsion. So whenever you are talking about emulsion, will have non-Newtonian properties. If you have single phase water, it will have Newtonian properties. So in non-Newtonian fluid, what happens? The Newtonian formula, first you have to know the Newtonian formula. Tau equals mu du by dy. Okay, in non-Newtonian fluid, the viscosity changes with time. So in that case, the figure becomes like this: shear rate, and this is shear stress. So Newtonian fluid will have curve like this, and shear thinning fluid, shear thinning and shear thickening. And this is Bingham plastic. As you increase water cut, the fluid from Newtonian, it will convert to other shear thinning fluid. So with pressure, its shear stress will change. So the emulsion will have shear thinning properties.